If you're in any doubt about how significant these new images are, I wish you could be in this room, because around me are the scientists, the astrophysicists, the cosmologists who really understand how they've changed our view of the universe.
Today, we're going to skip the typical introduction about the Webb telescope and dive straight into today's topic. It's essential to recognize that the findings from the Webb telescope are dramatically pushing the boundaries of our current astronomical theories. As we speak, the telescope stands on the threshold of revolutionizing our understanding of the cosmos and the fundamental laws that govern it. Recent observations from Webb have unveiled unexpected phenomena in the early universe, posing significant challenges to scientists worldwide, and suggesting that what Webb has discovered may critically undermine our standard model of cosmology. In an unprecedented revelation, astronomers have detected a mysterious structure located deep within the early universe. If you could experience the atmosphere in this room, you'd hear from the scientists, astrophysicists, and cosmologists who truly grasp the profound implications of these new images and how they are reshaping our view of the universe. According to the prevailing cosmological model, approximately 13.8 billion years ago, the Big Bang occurred, leading to a continuous expansion of the universe ever since.
New observations from the early history of the universe, what's called the cosmic microwave background, we're beginning to make very precise predictions of how fast the universe ought to be expanding today. And so we wanted to follow up on that by making comparably precise measurements.
However, many astronomers are beginning to question whether this 13.8 billion year time frame actually reflects the universe's age. Yet, for the sake of this discussion, let's maintain that figure. When we refer to the universe's expansion, we are talking about massive celestial bodies moving away from each other. As a result, the galaxies we observe outside our Milky Way are indeed receding from us. To ascertain the distance of these galaxies, astronomers employ a method known as cosmological redshift. Simply put, the greater the redshift value, the farther away a galaxy is from us. As light from distant galaxies traverses immense cosmic distances, it takes considerable time to reach us, suggesting that the more distant a galaxy is, the earlier in time we perceive it.
The usual explanation for this redshift is that as the light is traveling through expanding space, the photons themselves become stretched, so short wavelengths get longer. And this is known as cosmological redshift.
However, challenges arise in this observation. Light from these far-flung galaxies stretches into infrared wavelengths, which are undetectable by the human eye. The Hubble Space Telescope operates predominantly in the ultraviolet to near-infrared spectrum, which is why it has rarely identified extremely distant galaxies, with GNZ 11 being one notable exception. This galaxy, observed as it existed 13.4 billion years ago, just 400 million years post-Big Bang, has a redshift value of 10.957. This observation led astronomers to postulate that very few galaxies existed beyond a redshift of 11. Enter the Webb telescope, designed with the capability to observe in the infrared spectrum. Objects with redshifts of 11 and above can only be detected through infrared light, which opened a new frontier for astronomical exploration. Once launched and aimed toward the cosmos, the Webb telescope began to reveal a dramatically different portrayal of the universe, unearthing numerous galaxies that might represent some of the earliest known formations in the universe. Leveraging the early data from the telescope, astronomers sought out galaxies exhibiting very high redshifts, an indicator that these celestial bodies formed earlier than previously anticipated. As the telescope combed through the universe, NASA identified several galaxies that potentially formed only 200 to 300 million years after the Big Bang. Remarkably, this led to the discovery of what may now be the oldest galaxy in the universe, the Glass ZE13 galaxy, with a redshift of 13.2, formed just 300 million years following the Big Bang. The discovery of such a substantial number of galaxies in the universe's formative years suggests that we may need to reevaluate and revise our previous understanding of galaxy formation. This sentiment is echoed by the lead astronomer of this groundbreaking finding from the University of Missouri. He emphasized the significant implications these revelations hold for modern cosmology. He also mentioned that our discovery provides the first evidence that many galaxies may have formed in the universe significantly earlier than previously believed. While the new findings surprised the entire scientific community, another ancient galaxy was identified, existing just 390 million years after the Big Bang. So, what did astronomers uncover in the latest images from the Webb telescope? Recently, we have learned about multiple groundbreaking findings from the Webb telescope that challenge our conventional understanding of how distant galaxies emerged shortly following the Big Bang. There is a keen interest among people regarding the surprises that the Webb is revealing. Initially, they want to view the stunning images and understand the context behind them. Then they inquire about what's new. What have we discovered that was unknown before? The main revelations are that the earliest galaxies developed differently than anticipated, and the reasons for the inaccuracies in prior predictions are still unclear. Contributing to these discussions, the Webb telescope has made another important discovery regarding the early universe. The MIRI European Consortium's GTO team recently reported the detection of an extremely red object that was overlooked by most deep near-cam surveys. They discovered this object while searching for faint sources in the newly received images from the Webb telescope. Faint sources are significant because the Webb telescope captures less light from distant entities, making them appear dim and red in its images. While searching for these faint sources, the team came across an extremely red object that prior surveys had failed to identify. Scientists believe this object may be among the most distant ever detected. Nevertheless, sometimes nearby objects can appear faint due to dust clouds, but the team has dismissed that possibility. The object is extended and has maintained its position for a year, leading researchers to discard the notion that it's a brown dwarf within our Milky Way.
At present, scientists are uncertain about the nature of the object, but in a recent research paper, they have proposed 3 potential explanations. Initially, researchers speculated that the faint object could be a dwarf galaxy rich in dust, located around 4 to 5 billion light-years away. However, subsequent investigations have rendered this explanation less likely.